Hi everyone. This time we are going to talk primarily about infrared radiation. Now we have been talking about all of these electromagnetic waves going from long wavelengths towards our shorter wavelengths, and infrared is right next to visible red. It is just a little bit longer in wavelength than visible red, and the human eye just is not wired to see infrared. Infrared radiation is given off by any object that is warm, and it is due to the fact that molecules and atoms inside of your body are just oscillating or vibrating. The hotter a molecule is, the faster it vibrates, and the further from its rest position it vibrates. And it is that accelerated of charged particles within those atoms that give off the infrared light. Now, how big is an infrared wave? Well, these are quite small. They're about the size of the head of a pin. So tiny, tiny, tiny amounts of size. They're just really, really small. Humans do not see in the infrared, but reptiles do. And why do reptiles see in the infrared? Well, they're cold-blooded, and they eat a lot of little warm-blooded mammals like this poor little mousie over here. And so in the middle of the night, if he's slithering around and he's looking for a little warm morsel, the hot-blooded little creatures are going to show up to his little infrared eyes. Your remote control for your television, most of them operate in the infrared. And I don't know about you, but in our family, every once in a while when we get bored, we do trick shots with the remote. And we aim the remote. We're trying, the TV's over here, but we bounce the light off of a picture window or something and try and get back to the television. If you've never tried it, try it. It's kind of fun because they may not be visible, but the infrared rays actually bounce just like any other sort of light beam will bounce off of a mirror. Now, when we talk about infrared light, you might be familiar with heat lamps, whether you have heat lamps to keep your pets warm when you're away, or you just have tropical pets that like the heat. You go to a restaurant and they have heat warming lamps to keep the food warm. They are giving off wavelengths in this non-visible infrared wavelength, and that just produces lots of heat, and it's a nice way to keep things warm. Heat-seeking missiles are actually missiles that are designed to hone in on infrared wavelengths. And when an aircraft is trying to protect itself from incoming heat-seeking missiles, what it will do is it will throw this little chaff out that actually is phosphorus, and it produces little heat signatures, and the poor little heat-seeking missile gets all confused, and the aircraft can then get away. Now, thermal imaging using infrared, it can be used for lots and lots of different things. Many years ago, my husband and I had our home analyzed with infrared, and this was done from our power company. And a fellow came in with his little infrared camera and could show us exactly where we needed to put more insulation, where heat was coming through the walls, what were the hot spots, what were the cold spots. And so it's a wonderful way of actually seeing where you have heat losses in your home. Thermal imaging can be used in lots of different industry. This is an example in the food service industry for safety and health and safety. Something like food has to be cooked to a certain temperature. Well, instead of having a person with a thermometer running around measuring the food, you set up a computer with an infrared camera, and as long as the right color is being produced, then you know the food is going to be hot enough and you're not going to accidentally poison any of your consumers. Thermal imaging can be used in diagnostics. Obviously, this is a person where there is a different blood flow from left and right. So if something is hotter than it should be, that means that there is excessive blood flow. If something is colder than it should be, that means there's not enough blood flow. This is a horse's hoof, and this is a thermal image of it. And that excessive blood flow here would indicate that there's possibly an infection. Matter of fact, within the last week, I was talking to a relative of mine who's working for a company, and they're working on infrared technology for diabetes, and for people who have poor blood flow in the feet, that a physician could actually take a look at hands and feet and use this exact sort of thing, and immediately in the office could get a quantitative number of how good the blood flow is. Now, I don't know about where you live, but I live way out in the country, and our small town fire departments have had lots of fundraisers to have thermal imaging cameras for the fire departments. If they're going into a fire and there's a lot of smoke, the firemen need to know where are the hot spots, where are the cold spots, where might be people hiding that they need to save them and get them out. So this is just a whole realm of wavelengths that our human eye just cannot see. Infrared is interesting in the fact that it is absorbed and reflected by different colored objects. Things that are black in color, and especially things that are relatively dull as opposed to being shiny in color, are really good at absorbing infrared heat. It's also very good at transmitting infrared heat. This property of color and shine to absorb or reflect light is called emissivity, and that is a term that can be measured in science. A black wooden stove is not painted that way because it won't show the soot, which is also convenient, but it's painted that color because of the fact that black means that it will be a very good transmitter of heat back into the room. If you have solar panels tend to be quite dark. Why? Because you want the solar panels to absorb not just the visible light, but also the infrared. If you are trying to, this is kind of a do-it-yourself heater, if you're out camping or something like that, anything that's painted like a flat black is going to absorb lots and lots of light, including mostly infrared. One of the questions is always, what is a hotter or cooler colored car? Not cooler as in, ooh, baby, it's cool, but as opposed to temperature, hot or cold. And black cars are hotter than silver cars or white cars. Because of this dark color, it absorbs a lot more infrared. Now, if you want something that is going to stay kind of cool, you're going to try and have it a white or a silvery color. If there are reflectors, you want them to be silver and shiny. Tennis whites are not just a tradition, it's also logical that you're going to wear light colors in the summertime because it's going to reflect more infrared as opposed to absorb more infrared. If you've got a glacier that is white, it is going to persist and last longer because of the fact that it will reflect an awful lot of the heat radiation. And that's one of the reasons that glaciers that are hundreds, if not thousands of years old, have lasted that long. And it is due to the fact that white and silver are good reflectors of infrared light, not absorbers. Infrared light is also used by the police and it's used by the military. You may have seen pictures like this on various news feeds, and if you have a military background, maybe you've used some really high quality night vision goggles or something like that. Well, night vision basically means seeing with the infrared spectrum. And you can see things that are warm. Well, what's warm? People are warm. And vehicles that are moving are warm. This is one of my favorite pairs of pictures. This is a hallway that someone has just walked down. And you can't tell anybody has been here just in normal visible light, but you look at it in infrared and you can actually see the footprints. So it's really helpful for military and law enforcement. So there's a little bit about infrared, lots of good stuff. See you later.